So we're going to do some practice actually drawing vectors and working with vectors a little bit. And the best way to do is just to jump right into it. So here I've got a sheet. I've got 4 vectors. I've got A, B, C, and D. And what I'm going to do first is I'm going to measure them. Now, me measuring them on here and you guys measuring them on paper or whatever could be different. It doesn't really make that much difference for what we're doing. But I'm going to measure these out, how long they are, and get my measurements and angles I want to work with. So I'm just going to measure A, and if I measure the length of A, I'm getting around 2.5 centimeters. I'm not going to bother writing the centimeters right now, but I'm going to get a length of a 2.5. And that's the length of it. Now the direction, it's going straight to the right. I'm going to use angle directions for this. And it's going straight to the right. And if you remember, that would be 0 degrees, because 0 degrees is always straight to the right. Then I'm going to measure B. B is shorter. B looks like about half the length of A, so its length should be around 1 or so. And if I actually measure it, it is actually around 1, so I'm going to put 1.0 for the length. Now, direction-wise, there's 2 ways you could do it. Some people would wrap it around all the way around from 0 degrees. What they would do is they would go, remember, you want the angle is from the positive x-axis. They would wrap the angle all the way around, and that would be 270. So you could say at 270 degrees. Now, I don't really like using the 270. I would swing it back down this way, which would be -9 degrees, but it doesn't really matter which one you use. All right, so if I go to C and I measure how long C is, C I'm getting around 3.6 for length. Now for the angle, it's often good to put a little nub at the origin point. And what I often do is I will make a little nub and make a little positive x-axis. I know my angle has to be measured from that positive x-axis. So it swings up like this, so it's a positive angle, not very big. And if I measure that with my protractor, you know, that's the half circle angle thingy, I'm getting around 18 degrees actually, somewhere around there. So hopefully you're close to there. For D, my length for D looks about half as big as C, so around 1.5 or so. I'm getting actually 1.7. And again, I'm going to draw my little nub, draw a little positive x-axis, and I'll measure my angle from that x-axis to the vector is. It's past 90, and I'm getting around 125 degrees, so somewhere around there. Okay, so there's all my measurements. All right, now we're going to draw them. That's where you got to use a ruler, use a protractor, and you can draw them out. Now I can use my fancy schmancy computer tools here to help me out, but we're just going to draw these out. Now, there's 2 main ways to draw vectors, and which method you use totally depends on the situation. Now, what we're going to do a visualization here, because this is all about visualization. I'm going to draw a little guy. This little guy is going to go for a walk. Okay. Now, apparently, his walk involves vector A plus vector D. So what I'm going to start with is A, and vector A is pretty simple. Vector A is this. So he walked to the right 2.5 at 0 degrees, something like this. So he walked that way. Okay, so that's what he did. So this is his starting point. And again, it's often good to make a little nub for a starting point. So he started out here. And actually, I want to put the nub on the thing. There we go. All right, so there's a starting point. So he went to the right 2.5 at 0 degrees, because that's what vector A is. So I'm actually going to take my little guy. So he walked like this. So he walked over here. And then what did he do? Well, according to this, it's A plus D. And D is up and to the left. So apparently then he walked something like this. And if I would draw the vector, I'm going to just draw D. It would be something like this. And that's where the guy ended up. So you literally measure them. You literally use a protractor and then draw like nice scale diagrams. That's what the subtitle scale diagrams of what the combination would be. Okay, so then what's the answer? Well, the answer goes from beginning to end. It doesn't care about what happens in between. It's about beginning and it's about the end. So I'm going to draw a vector from my beginning to my very, very end, something like that. Okay, and that would be the answer. And then all I have to do is measure that red vector. Okay, now again, I'm doing this on a computer and blah, 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 and you're going to be a little bit different, but hopefully things will be close. So if I measure that one, and it's always from the beginning to the end, if I measure that guy right there, it can vary a little bit. It looks like it's around low 2s or so, somewhere around there. Again, there's going to be a little bit of give because people are going to draw a little bit differently. But it looks like it's around about 2 long. It's around 2 long. And the angle, you also have to have the angle. Now, remember, the angle is measured from where we start from. This is where we started from. If I draw a little positive x-axis, I go from my positive x-axis to my answer. So I got to take my protractor, I'm going to measure that angle right in there. And if I measure that, it looks like it's around 40 degrees in here. So the answer would be 2.0 at 40 degrees. And if we go back to the basics, if I asked you to draw 2 at 40 degrees, you would draw, nice little nub is good, a little positive x-axis. You would hopefully draw something, a line 2 long, and that would be 40 degrees, which is exactly what we have over there. Now, this method we're using right here, this is called well, there's different names for it, but this is often called the tip-to-tail method for adding vectors, where you draw one, and then you draw the next, and you put the tail of the second one onto the tip of the first one. It's called tip-to-tail method. Sometimes it's called the parallelogram method as well. There's also a free body method that I'll show you a little bit later on. It doesn't really matter which method you use it, but this is often called the tip-to-tail method for adding vectors. Okay, it's all about drawing it as best you can. And again, since we're drawing, people's answers are going to vary, and there's nothing wrong with that, so no big deal. We just kind of get a general idea of what's going on. We can worry about specifics later on. All right, so let's go to the next one. So the next one, we've got C minus B. So I'm going to start with C. So if I would draw C, it would look something like this. I'm going to draw it 3.6 long at 18 degrees, something like that. And then I am going to minus B. Now, I'm going to grab my little guy again, because he comes in handy. Let's see if I can get him out of here. Oh yeah, good. Okay, so here he is right here. So he walked C, something like this, and then minus B. Well, if it was plus B, he would be going down because that's the way B is. But if he does the opposite of B, well, minusing is like adding the opposite, right? So if adding B would be going down, minusing B would be actually going up. So minus B would actually be going this. When you subtract a vector, it's the same length, but you go the exact opposite direction. So it'll be something like that. Okay. So now I'm going to draw my resultant, same as before. I just didn't draw my little beginning nub, like my little beginning nub. All right, so I'll grab arrow tool. I'm going to go from beginning to end, and that would be the answer. So we're going to measure how long that is. And if I measure how long that is, looks like around 4. Looks like it's around 4 long. And then for my angle, I'm going to go my starting position, make a little positive x-axis, and then go from my positive x-axis to where my vector is and measure that angle. And if I measure that angle in there, it's around, give or take, it's around 30 degrees or so with my protractor. So my answer for this would be about 4.0 at around 30 degrees. So somewhere around there. So again, everybody's answer is going to be slightly off, no big deal. We just want to make sure we're drawing our vectors the right way, practicing measuring our angles and lengths and that type of stuff. Okay, so let's try a couple more questions. We're going to scroll this down a little bit to where the other ones are. All right, there we go. Okay, so you got A plus 2B minus C. We got D minus A plus C over 3. I think I might actually try and do them above the questions, and that way we can keep everything still in view. Okay, so, right, we'll start with that one right there. Okay, so with the first one, we get A plus 2B minus C. All right, we're going to start with A. So I'm going to start with A, and my A vector would go something like this again. And this is plus 2b. All right, now if it was plus b, b is going down. If I was going to add b, it'd be going down. But I'm not adding 1b, I'm adding 2b's. So it's really, really simple. All you do is you put in the b vector, you just make it twice as big. That's it. That's the only difference. Some people actually will draw 2 little b's. I just make the vector twice as big. Okay, and then it says minus c. So now we're going to do minus c. Well, if I was going to add c, it would go up and to the right like this. But since I'm minusing c, I want to do the exact opposite. So instead of going this way, I'm going to go something like this. Okay, so if I do that, I got my little beginning nub. My beginning nub was here. Actually, we can even draw, grab our guy. There's our guy. So he started, whoops. Let's grab our little guy here. Okay, so our guy started here. He walked across, which was A, and then he walked 2B this way, and then he walked a minus C over there. Okay, so then we draw our answer, which is actually called the resultant vector. You'll often see the term resultant. We go from beginning to end. There we go. There's my resultant right there. Actually, I could write that down. This is called it's called the resultant vector. All right, so I'm just going to measure how long it is. And if I measure how long it is, it looks like it's around 3 or so, maybe a little more than 3. And then I'm going to measure the angle. And if we measure the angle for this guy, it's not quite, mine's not going quite straight down, it's going straight down to the left a little bit. Again, you want to take the angle from the positive x-axis. You could then measure it all the way around this way. This would probably be easier to measure with a protractor going down that way. And it looks like it's around, measuring the protractor, look around about 100 degrees in there, somewhere around there. So my answer for this one, it's around 3 long. And you could say negative 100 degrees. And of course, it's negative because I'm swinging down. Or if you wrapped it all the way around, you could also say at around 260 degrees. It doesn't really matter which one you use. I would use the negative 100 because I find it easier to visualize. Okay, so that is that one. So when you're multiplying the vectors, like you just make it, if it's times 2, you make it twice as long. If it's multiplied by 8, you make it 8 times as long. If you multiply by 0.5, then you make it half as long. Okay, and that's basically how it works. All right, so let's try the last one here. Okay, so we're going to draw d minus a plus c. Okay, no big deal. So first I'm going to draw is d. And d looks something like this, give or take a little bit. There's my d vector. Okay, and then I'm going to draw minus a. So if I was going to add a, I would go this way, but since it's minus a, I'm going to swing it around the opposite direction, something like this. And then it says plus c over 3. All right, so if I was going to add c, it would do something like this. But it's not c, it's c divided by 3. So all I have to do is just divide the length by 3 and make it 1/3 as big, which would be something like this. Okay, so again, I'm going to draw a little beginning nub. That's where I started from. I often will draw my little nub and actually just draw a little x-axis just to start out with because I know I'm probably going to use it. All right, so next I'm going to draw my resultant, which goes from the beginning to the end. And there's my resultant vector. And then I just have to measure how long it is. So if I measure how long it is, it looks like it's around 3. We're going to measure the angle. This angle right in here probably easier to measure right in there. So if I measure that angle in there, looks like around 40 degrees or so when I measure with my protractor, somewhere around there. Okay, but that's not the angle I would use for my answer because my angle for my answer has to come from the positive x-axis. So if that's 40, then I know that would be 140. So my answer for this one, it's about 3 long at around 140 degrees, so something like that. So that would be d minus a plus c over 3. Okay, and that's basically how we draw vectors, sketch them out, and extract the values and apply values to them. Now again, since we're drawing and using rulers and protractors, all you need to do is get approximately the same answer. You're good to go. It's all about, making sure the angles are going the right way, drawing, right and up instead of, left and down, simple things like that. We'll get to the precise method a little bit later on, but this is generally how it works. Okay, and that's how you draw vectors. And vectors are used for tons of different stuff. I mean, you see signs with arrows on them all the time. I mean, those are vectors. I mean, whether they're traffic signs or an arrow in an airport, turn left, turn right. They're everywhere, and they're used for lots of different things. So, but that's the basic idea of how to draw vectors. Again, this is called the tip-to-tail method. And if nothing else, draw a little guy and have the guy walk around. You walk this way, this way, this way. It's often a great little visualization of what's going on and seeing how things actually piece together. Okay, and as you more and more of them, you just sort of pick up on it and things sort of start clicking, and that's about it. Okay, the nice thing is this isn't exactly complicated math. It's using a ruler, using a protractor, and that's it. Like, that's elementary school mathematics. And it's a really simple idea. And once you get the hang of it, you'll be good to go.